Hello and welcome to the TutorNet channel. Today we are going to be discussing the rules of exponents. First, we will discuss the product rule for exponents. The product rule for exponents states that x to the a times x to the b is equivalent to x to the a plus b. In other words, to multiply two exponents with the same base, you keep the base and add the powers. So let's do a couple of examples. So first, we have 2 to the negative 2 times 2 to the 5th. So based on the product rule, we know that this equates to 2 to the negative 2 plus 5 power, which equals 2 to the third power. 2 to the third power we know is just 2 times 2 times 2, which is 8. Let's do another example. So we have 4 n to the 4th times n times 4n squared. So we know that we have to multiply the coefficients first. So the coefficient of the first term is 4. Coefficient of the second term here is just 1 times the coefficient of the third term, which is 4 again. Now we take care of the n. So again, since we're multiplying exponents, we have n. Based on the product rule, we can add the exponent. So n, the first exponent is 4, plus, we know n is the same as n raised to 1, so plus 1, plus 2 for the last term. So we know this equates to 4 times 1 times 4 is the same as 16 times n to the 4 plus 1 plus 2 is 7. So our final answer is 16 times n to the 7th power. Okay, let's discuss the quotient rule. The quotient rule for exponents states that a to the m power divided by a to the n power is equivalent to a to the m minus n. In other words, to divide two exponents with the same base, you keep the base and subtract the powers. So let's do a couple examples. So we have 2 raised to the 8th power divided by 2 raised to the 5th power. So based on our quotient rule, we know this simplifies to 2 raised to the 8 minus 5, which equals 2 to the third power. And we know that, again, is just 2 times 2 times 2, which is 8. Okay, let's do another example with the quotient rule. So we have p raised to the 9th power divided by p raised to the 3rd power. So again, based on our rule, we know this simplifies to p raised to the 9 minus 3, which is p raised to the 6th power. Okay, let's discuss the power rule of exponents. The power rule states that x raised to the a power raised to the b power is equivalent to x raised to the a times b. In other words, when you raise a power to a power, you multiply the exponents. Okay, let's do some examples. So first we have 2 raised to the 3rd power raised to the 2nd power. This simplifies to 2 raised to the 3rd times 2. And this is 2 raised to the 6th power. Let's do one more example. So this time we have 2x to the 3rd all raised to the 4th power. So always remember the exponent has to be distributed to everything inside of the parentheses. So first we have 2 raised to the 4th power. Then we have x raised to the 3rd power times 4. So 2 to the 4th power is 16. And x raised to the 3 times 4 is 12. That's our final answer. Okay, now we're going to discuss the negative exponent rule. The The negative exponent rule states that x to the negative n is equal to 1 over x raised to the nth power. In other words, negative exponents in the numerator get moved to the denominator and become positive exponents. And the negative exponents in the denominator get moved to the numerator and become positive exponents. Okay, so the first example is going to be 1 over a to the negative n. So this simplifies to 1 over a to the n. Since a to the negative n is 1 over a to the n. So if we simplify this, this is 1 divided by 1 over a to the n. And we know that when we divide fractions, we use the keep, change, flip. So we keep the 1, change the division sign to a multiplication sign, and flip the fraction, so a to the n. So this is equal to 1 times a to the n, which is a to the n. So again, this just goes back to what we discussed earlier. Whenever there's a negative exponent in the denominator, it gets moved to the numerator and becomes a positive exponent. So we have 5 to the negative 2 power, which equals 1 over 5 squared based on our rule. So this is equivalent to 1 over 25. And let's do one final example just to make sure we're understanding. So we have x to the negative 2 over y to the negative 3. So we know x to the negative 2 is the same as 1 over x squared. And again, here we have y to the negative 3 in the denominator. So it will move to the numerator and become a positive exponent. So our final answer is y raised to the third power over x raised to the second power. Okay, moving on to our final rule, we're going to discuss the zero exponent rule, which states that anything raised to the 0th power is 1. So a raised to the 0th power equals 1. Now let's do an example. Let's just say we have x to the 5th to the 0th power. So again, we can use our product rule here, which we discussed earlier. And this is equivalent to x raised to the 5 times 0th power. And we know anything times 0 is 0. So x raised to the 0th power is what we're left with after multiplying 5 times 0. And we know based on our exponent rule that this is 1. Okay, this wraps up our discussion on the rules of exponents. Thanks for watching. Please comment any other topics you would like us to cover. And please don't forget to like and subscribe. Thanks.